Okay, we're going to take all the code that we just did with array operations, and we're going to convert as much as we can to functions. So let's take this very first one, the measurements array, and we were summing that. Let's change this up now to where we will just send the array over to the function. And then over there, that function is going to do all the math, figure out the sum, and then it can return the sum from the function. So let's get that coded real quick and see the exact same behavior, but just written a different way. All right, let's start to pick this apart. First, here's my function call in main. I'm just going to call it getSum. And I'm going to just send an argument to it. I'm going to send measurements, and that's the measurements array. So to send an array to a function, all you do is send the array name, just like a variable. If we're going to send a variable to a function, we just send the variable name. Well, we're doing the same thing here now with sending this array. Here is a function prototype, getSum. It's going to receive a double array, an array of doubles. So that is our syntax right here to show that, yep, that's going to be a double array. And then it's going to return a double, which is going to return the sum. Let's go down now and look then at that function definition. So now remember, this function header is going to match the function prototype, with the exception that there will be a semicolon in place of this brace, and you don't put a parameter name up in the prototype, just in the function header here. And then this code is really the same as before. We had a summing variable, an accumulator, set it to 0. And then inside that loop, we're just going to take whatever array value is and just sum it. So that's the exact same code as we had before. And of course, this function then will return the sum. And that's important to note because sum is a double and it has to match that data type right there. And then back up here in main then, this time I'm going to just simply count the return value. We could also store that in a variable. We could also put it in an expression. But I'm going to choose to just count it here. And let's run this now, and we get the same 683.8 that we did previously. So we're just sort of outsourcing the summing operation. Now, interestingly, you can do this and you will get the same results. So as part of our work in functions, we saw that you are allowed to code the function first and then the main function. But I also mentioned in that video that your programming team is going to get upset at you because if there are 50 functions in this code, they're going to have to sit here and scroll and scroll and scroll and scroll just to find out your main function. So it's most common practice to put main first and then all of the other stuff. But this will compile just the same, and you'll see the exact same results. Okay, well, let me reset this then to using a prototype, and then let's go down to the next section. Oh, before we move on, I want to update our measurements. I'm sorry, our getSum function just a tiny bit. And here's why. Let's suppose that we had a second array here of doubles. I'll just call it ARR2. And let's suppose this is of a different size. I'm going to just say 10 without coding in that yet. Let's do a size 3 constant up here. for 10. And now I can put that down here. So the thing is that this getSum function, it should really work regardless of the size of the array that it gets sent. It should just sum up whatever it's sent and then go on its merry way. But look at our function definition down here. We see that it's not going to do that. It's always going to use SZ1 here. So we need to fix that. So let's fix it by, let's just make the programmer decision now that they're going to also send us, as part of the package of parameters that we get when this function is called, we're also going to get an int size. So this for loop now can just go up to whatever amount the function call gives us. So this means we have to add an integer here as our second parameter. So we've got two places to do that. We've got to still update the prototype, and then we have to update the call. So let's do the prototype first. That one's going to be easy. We're just going to add in an integer into the parameter list. And then now in our function call, let's throw in, well, which constant are we talking about here? So we'll throw in SC1. Now you'll see here, I'm going to try and intentionally create an error. By calling getSum, and I'll throw the second array at it, array2 here. Let's throw that at it, but I'm only going to send size1 to it. So it's going to try and process 12 elements of this array, but only 10 elements exist. And you can see that we got some weird output here, this NaN, that stands for not a number. And we got that because the last two iterations of this for loop were trying to add numbers that don't exist. So we got the not a number. So it's going to make the most sense here to, let's go ahead and send the right size of the array, and then we'll get better results. And we got this right here, so we know that that's working. So that's a little better way to create a function that is truly able to be reused and reused, regardless of the size of the array. Otherwise, we're stuck. We can only use that function for arrays of size 12, and that limits its utility. Okay, well, there is sum, and our next thing that we had coded was this min-max. Let's figure out how we can kind of outsource all of this code to a function, and we'll just send it an array. Let's also send it the size, since we, that array will have a for loop in there somewhere, and we will need to have that size. So let's figure out this code. Let me go ahead and code it now, and then we'll walk and talk through it. Okay, here's max and min. Let's look at the calls first that I coded, the function calls. First, I renamed this measurements array just to something smaller, just so I don't have to keep typing it out. And I'm going to do the same thing that I did in the code block above. The return value, let's just count it. We could easily store it, save it, whatever we want to do, but I'll just count it here. And so note, I'm just counting max, and here's the max, min, and here's the min. I'm going to create two functions. One is getMax and one is getMin. Remember that arrays can only return one value. So it'd be nice if functions can only return one value. It'd be nice if this function could return both the min and the max, but with C++, functions only get one return value. That's why later in our programming, we could easily return an array here with both the max and the min in it. We could also use reference variables, which you'll get into more in CompSci 165. and just simply use those and get those back. So we'll just create these right here, get min and get max. And let's take a look at those function prototypes. We're going to do the exact same thing that we did with get sum, and that is we'll send the array. Here's the double array. And then we're going to send along with it a size declarator so that the for loop knows how many times to go through this loop. Now let's look at the function definitions themselves. Max and min are going to be just about identical, so I'll just kind of go through one. Here's that parameter list. That's the same as before. We're going to receive the array. I'm just going to use a parameter array name of A, just something temporary. And then here's the size. So because we're sending size in, we can now actually use that variable inside this for loop. Now remember, with max and min, we've got to initialize it to the first value. So this is doing the same thing. We're going to set min and max to a sub 0, whatever that first value is. That means our for loop can start at 1 and start looking at the second element, because the first one has already been evaluated and assigned to both min and max. Then there's our for loop. Here is our typical algorithm. And then after that loop finishes, we'll just return the max. So running this now, yep, you see, all right, there's our max and our min of 98 and 12. And if we looked at that, we could see that, yep, those were the ones. So we've successfully outsourced this min and max calculation to a function. Now let's make a function out of the comparing two string arrays functionality. So first, take a look at my function call here. We're just going to send to the function the two string arrays and then also a size declarator, so the for loop knows how many times to go. And let's make this a Boolean function. It'll simply return a true if they're the same, a false if they're not. So then our output here is saying, all right, if it's false, go ahead and print out that word not, just like we had before. Otherwise, it won't print that out, and we'll get the string that the names are the same. So let's run this, and we'll see that we get, yep, names 1 and 3 are the same. Let's try it now with names 1 and 2. So I'm going to just change these. And we get 1 and 2 are not the same. Let's try 3 and 2. And 3 and 2 are the same. There, let me fix that. And here we get, they're not the same, and that's correct. And now let's try 3 and 1. We already did 1 and 3. This will be the same thing, but just to show that, you know, we can reverse them. And this shows that they are the same. So that's our functionality of the call. We're just going to return a Boolean. Here's the prototype. I'll call the array or the function name ARR same. It's going to return a Boolean, and it's going to receive those 3 parameters, both arrays, and then an integer with the size. Looking at our function definition down here, then, here it is. And we just simply outsourced all of the previous code that we had to this function. We just cut and pasted, and then wrapped a function around it and updated the parameter names and updated the return value. So here is that temporary Boolean that we will end up returning down here. This for loop is just going to go through both arrays up to size, and here's that exact same code as we had before. If a sub I is not equal to b sub I, then we do those two tasks. We flip the Boolean to false, and we break out of the for loop. So hopefully pretty straightforward on these comparison operations for arrays. Let's take a look now at copying arrays and how we could do that up in a function. Actually, no, I'm going to skip that, and I'll explain why in a bit. Okay, here is the deal on returning an array from a function. Now, I said I was gonna skip that last part. Actually, I'm gonna show you how we could code it using sort of a cheat. But with C++, you cannot return an array from a function natively. And what I mean by natively is just the normal array that we have, and using a return statement, to return some array that looks like that. We can't do that. You'll learn how to do it in the context of the broader discussion on pointers that you'll get in Comp Sci 165, and it's in chapter 9 of the book. With pointers, you can do this. You can get a reference to an array returned using a pointer. But there's this thing about pointers and arrays in C++, though, where they're sort of the same thing. So another way to return an array is within this broader discussion of reference variables that you'll get in Comp Sci 165. It's sort of beyond the scope of this class. But just in a nutshell, an array can be passed without reference variables to a function. So what this means is if we have a function over here, and then here's our main function. If we had just a normal integer, and we sent this integer over to the function, saying change the integer, and it says somewhere in there that a is now 100, we know that in the absence of a return value, that when we get back to main, a is still going to be whatever we initialized it as. It doesn't change in the main function to 100. But we can use reference variables for this, and that's what you'll learn on Comp Sci 165. But another thing that we'll learn in 165 is that, well, with arrays, if we had some array like this, and we send that, well, it's going to work now. And that's because arrays will do this manipulation without needing a reference variable. So if we send an array to this function and the array then manipulates it somehow, and we don't do a return, we're still going to see those changes evident in main. So let me show some code to kind of explain what I'm talking about. Here's a main function with a values array of just these 3 values. So I output them, and we can see here in the output that I get 642. Those are the correct values. Now I am going to create this function, and note that I'm going to just code the function definition above main here for the purpose of readability and fast. Normally you'd create a prototype and then put this definition down, but I'm just going to put it up here just so we can be fast about all of this. So my next statement is that I am going to alter array. I'm going to send values and then an integer, a size, up to alter array. So here's what's happening now in alter array. The parameter name is z. So the array name is going to be temporarily z, just like size is that. And alter array is just going to take every element of that array z and multiply it by 100. So when we run this, we see that, yeah, this array got multiplied by 100. Here's the final count statement there showing this. But you'll note that the array here never ever returned anything. It never returned the updated array. And yet the change is evident in the main function. Let me add in another function here to alter a variable. And let's call that variable y. And let's do y times equals 100. And let's try that. Here is an integer v. I'll name it assign it 10. And then let's send alter var up to this function. That's going to multiply it by 100. But note there is no return statement. This is a void. And then let's see what the value is of v here when we output it in line 16. Well, we see that it's 10. So this variable, those changes were not persistent or not evident or not carried through in main. The function altered it, but it didn't carry forward, and those changes aren't evident in main. But with this array, the changes are evident in main. So that's the difference in behavior. Okay, arrays will automatically get altered, and variables will not. So I'm going to recode now that segment of our function demo, and let's kind of leverage this behavior here and do it that way. So here's our code block that we had used previously for copying arrays. And here are the two arrays in play. One is the original readings array, and we're going to create a backup copy of it. Now, look at my call here. I'm just going to call copy array. We don't have to assign a return value, because this is one of those with arrays where we don't have to follow those rules, where we've got to either count it, use it in an expression, or assign it to a variable. Well, with an array, you don't have to do those. It's just going to happen. Those changes are going to be evident. And then here, I'm going to do a real quick range space for loop just to validate if those changes are evident, and if we in fact have a copy of the original array. So running this, we see, yep, there is the copy. That's the output there. So let's take a look then at this function copy ARR. Note that I coded it such that we're sending the three arrays to it. I'm sorry, two arrays, reading and backup, and then also a size declarator so the for loop knows how many times to go. Okay, well, let's look at that function definition down here. This is it, copy array. Like we said, it takes two double arrays and the size declarator. Here's our for loop. And we're doing the exact same thing that we did up in the main function in the previous video. And that is just assigning whatever A is, we're just going to assign it to B. So the old is being assigned to the new here. But again, notice that there's no return statement, and yet these changes are evident in our main function because we just output it here. So that's a pretty cool trick. Remember that, you can leverage it, and it'll help you sort of get by until you learn more about reference variables and pointers in Comp Sci 165. Okay, gang, probably a way too long video. Good luck, and we'll see you online. And good luck in this module. We're almost at the end, so hang in there, everybody.